Okay. Acha, before going to this one, everyone is here.
Yes, sir.
Everyone. Everyone. Sujay, you are here.
Yes,
Okay.
sir.
This is what I was telling about. Dotla Sai Krishna has joined. Who is not there? Acha, one request from my side, which I got from VLSI tutor, but this is from my side to you guys. Open your LinkedIn. Okay.
Yes, sir.
Open your LinkedIn, and from there, if you will search here, right, VLSI tutor. Daily we are posting it something here. My screen is visible, right?
Yes, sir.
Daily we are posting something here like 9 hours. If you will see, right, synthesis flow, everything. There are so many things in synthesis that has been uploaded here, like in very details also. Similar thing, everything you will find similar only, but it's just like some nomenclature. See, sin to gen, sin to mam, sin to up. So this is based on genus, which I told you. Sin to gen is elaborate, sin to map is compile, and sin to opt is compile opto. So that optimization. So that is the, so everything is there. So if you will go, you will be able to read. So just go through each and every post. One request from my side and the VLSI tutor is try to repost this. So at least every day, and the like. And if you like, please comment it out. This is why I'm requesting is we want to make it to reach out to so many people who are in need for these things. Okay. So you know how to repost this. These three things you will do. Comment it out whatever you like. And if you are like not liking also, that also you comment whatever you not like. That is, I'm okay with that. But do like, do repost. Guys, could you do
Sure,
this
sir.
for me?
Sure, sir.
Yes, sir.
Everyone,
Yes, sir.
everyone. Daily you will get this. I will send you this, like I will, or like anyone, Anubhav will send you this link. We will send you this IVLSI link. So just go and read it out. It will be how many? 3 minutes straight. So if you will click here, right, you will see this what synthesis flow is. Synthesis flow it has written here. Whenever you are coming to the classes, right, you just ask me like this thing I am not understanding from here. Okay, and give me the feedback whether you are liking it or not liking it, right?
Okay, sir.
Okay, so this will help you also to, what happens, I will tell you. Whenever you read two books, right, one book, the regular book, whatever it will be taught in your classes, that is one regular book that you will be reading. But once you are taking some one or two another book, it will help you to understand. So this is how we have tried so many things. DC synthesis flow also, right, DC flow, and design compiler. This is something you will see, the genus flow. This is how I have tried it. Okay. So from the VLSI tutor, this request has come. So that is where they said that just ask everyone to retweet, tweet this. It's a repost, not retweet. So it's not Twitter, right? So repost this, and please like, and if you are liking it, please comment it out. This is like I'm requesting. Okay. Every day you will see this. So this is what
Yes,
we
sir.
are doing is 101 day of PD. So this is day 10. Another 91 days you will find every day you are getting something. And it will be 2 minutes read, 5 minutes read, 10 minutes read. That's it. So do repost. I will see like who all are reposting it. That is for sure. I will get the feedback on that one. I'll see that, and do repost and like this. Just make it to reach out to the people, those who want to actually, if they are not getting these kind of sessions or the training programs. And if I have seen so many people, if they are not able to pay also the huge amounts in lakhs or in 2 lakhs generally the people ask for. So if they are not able to do it, they can read it out, they can learn it from here as well, right? So we are trying that way also. And do follow this VLSI tutor, all of you, 12, 15. How many of us are there? 13 people, not 12. 12 people are there, right? At least 12 repost and 12 likes from you guys I will see from tomorrow. It's not burden, right, for you guys?
Yes, sir.
It's not burden, right, for any of one of you. So
No,
this is
sir.
my request. Like yeah, so it's like anyway, it's like your choice, but it's my request that if you will do, I will be happy like seeing that. I'll get the feedback from VLSI tutor. How many of you are actually doing that? So yeah, please do that. Now, any doubt in the optimization? This one, any doubt? Any doubt?
No, sir.
Anybody is having any doubt? The story is clear.
Yes, sir.
The story is clear for everyone. Now, coming to that. So now we will go one by one optimization. Note it down. I will give you time, but first understand. And if you right now only ask yourself why. If you are asking yourself why, you will get the answer. Okay. So let's see how this will go. Data path optimization. So synthesis one optimization is data path. What do you mean by data path? Every word has a meaning. Data path, optimization, carry, save, addition, transformation. What do you mean by data path optimization? So what happens? Basically, I will come to the paint again. I'm removing this. Okay. Whenever you have designed, right? Whenever you have designed. So there are basically how design will actually look. I will start from the. This is my input port. This is my input port. This is my these two registers. This is my output port. This is my output port. Now see, this is connected to here. In between, few combo logic cells will be there. Combinational cells will be there. And generally, I take these paths. This is easy to understand, right? And then one path will be there. The clock path it will be there. So that clock, if you will see, right? See all these. I'm doing just to create in PPT also. This is clock, right? Similar way here also the clock will be there. Similar way clock it will be here. Now if I'm going from here, right? Here, here. This is the clock port. Now for this one, here, here. This will be a clock. Now clock is ideal since we are in synthesis. So this is input port. This is input port. This is output port. This is launch 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 register launch res. This is capture. Note it down. Capture. This we will see in all the timing paths just to during analysis. Capture. Capture register. Capture register. Capture flop/flop. Okay. Now this is combo logic. Combo logic. Whenever it says that this is data path optimization, data path means it will be there are basically two paths it will be in the design. One will be data. So data might be from into this register deep in and from this clock to queue and this combo logic to this deep in or this output to this queue. This again this goes like this clock to queue, right? And one will be clock path. Clock path will be whatever we are getting the clock, getting in the launch and the capture, both. Agree with this point?
Sir. Yes, sir.
Agree, everyone? If you are
Yes,
not
sir.
agree, if you are proceeding, you will not understand.
Yes, sir. I
So
agree,
right
sir.
now, tell me. Agree, everyone?
Yes, sir.
Question we agree with this.
Yes, sir.
Yes, sir.
Aditya, combo logic, combinational logics. So this combinational logic, I will explain you what are here. So many adder, mugs, so many things will be here in between this. Maybe it will be only buffer only. Many places you will see, but this is what the data path it is called as data path. So data is traveling. So there are two, data and the clock. Clock is traveling, data is traveling. So here it is looking for data path optimization. See, one word, just to explain one word, I need to tell you all the story. Why? Because I don't want to skip anyone a single doubt that what data path, and may you might forget after one day or couple of days that what data path is. Okay, carry save addition. Now, have you heard this word carry save any time earlier?
Yes,
Yeah.
sir. Edison
Where?
time.
Where?
Edition.
Carry save
Edison, sir.
adder.
Edison. For
Ah,
example, we take half adder. There are
half adder, correct. I will tell you, every arithmetic operation, whatever happens in your circuit, right? Every arithmetic operation will happen through this half adder or full adder. Okay. So now we need to understand this half adder will come here to do the calculation in between these registers. So this how we will optimize that. You remember that what we have taken, where is this? From here to here it was there. Imagine this is flop output and this is launch flop output and this is launch flash input. Now you can correlate this.
Yes, sir.
So this is how it is. This is where we started, this is where we ended. In between the number of logics are there. Now we have to optimize in a way that our timing performance will be faster, power will be less, and timing will be area will be less. Clear? Clear this one?
Yes, sir.
So now what I will do that this will happen. So this is called carry save addition transformation. This we have to do. That means adder transformation we are doing, half adder transformation. Now I will tell you. CSA carry save addition transformation. This is the optimization name. Data path optimization or carry save addition transformation. This optimization name is like this. CSA transformation results in most efficient arithmetic circuit which is smaller and faster. So if you will do addition with all the different gates and everything, right? Compared to that, this CSA transformation, this full adder, half adder, not full adder, half adder, this carry save, this transformation will give you the smaller circuit and the faster circuit, right? Adder, subtractor, multiplier are transformed using this carry save addition. Adder will be, it might be full adder, right? It might be subtractor, multiplier, any other. This will be converted into carry save addition. Steps, how it does? Arithmetic components are converted into half adder. This is what I was talking about. Half adders, and these half adders are used and merged to produce a smaller and faster data path. Simple. Now tell me, anybody is having any doubt on this one? These four lines. If you want, note it down, then we will discuss. But this you need to remember that. Once you guys are done, let me know. I'm waiting for you guys. Once you guys are done, let me know.
Done.
Everyone done, right? I'm proceeding. So this data path optimization, you got it right. Data path, how if in between some arithmetic circuit is coming, like different adder will come, we will see so many circuits onwards. So those circuits are coming, it converts all these components like adder, subtractor, multiplier into half adders. Like adders, here if you will ask what this adders mean, this is full adder, right? And if it is half adder, then what it will convert to half adder? It is already half adder, right? So you must have seen the optimization in the digital logics in like third semester or fourth semester, that we are changing that, like convert this circuit into a half adder circuit. Have you seen that? Remember?
Yes, sir.
Remember
Yes,
that?
sir.
Those I actually want to take it here. I'll just note it down here, that put some conversion so that people the mind will get open. Keep some logic circuit which can be converted into which can converted to half adders only. Okay, next time I'll just
We
keep
can take
this.
one more example also, like 4:1 marks to 2:1 mark. Also, like for optimization.
Those optimization will come. We have those optimization. I will tell you. But
Okay.
here, this is only for the
Added.
arithmetic circuits. Yes, mostly adder, subtractor, and multiplier, not the mux one. What you were talking, I understand, Tejaswini, but it's the like there are so many that we will discuss. So definitely those optimize. It's just the logic conversion. Why I took here that we have done so many of logic converted conversion to half adder, and I remember that like we used to get 2 to 3 marks questions on this one also. Like what will be the logic circuit if this is the output for using half adder only, right? We were getting some arithmetic equations, and from there we used to get it. So it was very easy to note it down in like a plus b plus c plus d, and into it, this much, like, right, ef. But it was like it was taking some time to convert it to half adder. So this I remember actually, we like everyone of us had gone through that. So remember this. This is data path optimization, carry save addition transformation. This is arithmetic circuit, where arithmetic circuit means what? Arithmetic mathematics, we have seen that arithmetic, right? So adder, subtractor, and multiplier. Mostly these three will be there, and this three will be transferred to half adder. Multiplier circuit is a delay will be more in multiplier circuit or in subtractor or in full adder. That is the reason we are changing it to half adders. Okay, clear, guys? That actually produce the smaller and faster data path. Okay, next. Now, few arithmetic expressions optimization. This I will tell you. So what happens whenever we have this a plus 2 star b minus 2, like different constant, yeah, operand folding. This also we have seen in digital electronics, that if this is there, right, this can convert to, just see this how this equation will, a will cancel a, 2b, right, and plus b, this will be 3b, and here plus 7 minus 2, it will be 5. So 3 star b, this is the only equation it has been remaining. So if this kind of equations are coming in the RTL, understand this, if this kind of equations are coming in the RTL, we need to convert these things first to a arithmetic optimization, then take that circuit and try to convert that into the circuit. Try to convert this into a circuit. So this is 3 star B. What it will come? One AND gate will be there. So OR gate will be there, where one constant logic, one that 5 will come from one side, and one side 3 star B will come. Only one cell, correct? But imagine if these many cells are there. If RTL will not first do the arithmetic, this constant and operand folding, then what will happen? These many things we needed, correct? Here you will see one like multiplier is there, one addition is there, one subtraction, one addition, subtraction, one addition, like that it will come. So we are basically, before going to, if you remember, right, before going to elaborate stage, whenever it is converting that to the GTech cells, before going to that only, we are going to have this, correct?
Yes, sir.
You mean before detect, right?
Yes, before converting to the cell only. So once they do this optimization, they will be getting, like, internally we are also doing, right? So tool will actually see this, not this, right? And once tool will see this, it just need one OR gate. It don't need like this, these many adder and subtractor. Imagine 5 6 cells will be here. Here only one smaller cells. 5 6 addition subtractions are there, including, right? Which one
Yes.
you will go for?
Right hand. Right side.
Right side, right? So that is where this operation constant and operand folding happens. Try to take that. Try to take that. Why I'm telling you try to take that? These are the optimization at the RTL level, right? Few optimization. This, like, it's a very simple that adder, subtractor, multiplier will be converted to half adder. This we know that in digital electronics we have done a lot. There also we have seen that it has given us a better result, right?
Yes, sir.
So here now similar thing, but here it has already converted to these cells, and then it is doing the transformation. But here, before transforming only, it will do the calculation, and then it will come to the final numbers like what it should be, right? Now understand common sub expression. So common, we have seen, right, few pieces will be in. Just understand from the example, then I will come to common sub expression sharing, how sharing happens. So z1 equals to a plus b plus c, z2 equals to c plus d plus b. So we have taken one variable, that is t equals to b plus c. You will see this is common, b plus c, here also this is common, right? So every time I don't need to take, like, whatever it is, the this adder, just to make the simple. So if we are making this using this common sharing for the sub expressions, in between these expressions we have, like, huge expressions will be there. In between, if we are seeing this kind of sub expressions, then we can take the common sharing as one variable, the way we were talking about the variable, right, in the tickle. Similar way here also we are taking one, and that we still we will be using for this operations, right? So the complex circuits will get converted into the smaller circuit in terms of, like, the simple circuit, right? These are mathematical operations, but tool does that. So I just wanted to tell you guys also that tool does at this level also. That's what building blocks happens during the elaboration, right? And that it does, and then after it goes for detect optimization, if you remember the flow. This also we have seen in digital electronics, product of sum of product. How many of you remember this one?
Yes, sir. Yes, sir.
Right? So sum of product might be converted to you can mute yourself. You can mute yourself. Sum of product. Now what is that?
Minton's max terms.
Kind of. So these are the things, like, we have already studied. If you remember the digital electronics, when we started that time only, very first chapter it was there, these things. So these, why it was there during that time? See, when people pass out the BTech, right? Many of my friends will tell me that whatever I have studied in BTech, it's worthless. Many of my friends tell me. I tell them that whatever you have studied, everything is there. You just need to change your view. I tell them. So this we have already studied, that product of sum of product. Here two multiplier will be there and two multiplier will be, what will be the circuit of this one? What will be the circuit of this one? Use your mind.
Two AND gate and one OR gate.
Or get right. And here what it will be there?
One AND gate,
One OR gate and one more input with an AND gate. The
So
output of an OR gate will
how many
become
cells are here? How many cells are here?
three,
How many are here?
two,
two,
Which one you will go with?
second one.
two, right side.
Clear?
Yes,
Everyone,
sir.
it is clear.
Yes, sir. What is sir?
Rafat, clear for you?
Yes, sir.
Suzanne?
Yes, sir.
Hey, today David is here or not?
Yes, sir. Hello. Hello.
Hey, David, you are getting the point?
Yes, sir. Yes, I'm getting.
Yes. So, any doubt, anything?
No, sir.
Today you have not interacted, so I thought you were not present in the class.
No, sir. I'm.
Yeah, yeah, that's okay.
Okay.
So this is clear, right? So now two cells, which you will go for?
Right side. Right side. Simplified version.
Ha. So then second one is comparator sharing. Like this is the last one, comparator sharing. So now see, Z equals to A greater than B, Z2 equals to A less than B, Z3 equals to A less than C. So like this comparator sharing, whatever we have, right? So we can utilize this one also if it is like, like I can take some more better example, like whenever some logics are higher and lower, so which one it should pass. So whenever we have, just imagine if mux is there and we have select line, right? So which one it should go. So like that, those kind of comparator circuit it is there, right? So these are the basic actually equations that we can see during the elaborate stage, how RTL is getting converted to the gate level netlist, right? Okay. Parallel constant multiplier optimization. So again, temp equals to in one plus into out one equals to temp into, like this is the value 105 64 32, like 64 bit, 32 bit, 8 bit, 1 bit, like 1. Out 2 is 621 105 512, 512 bit is there and 4 is there, right? So these kind of comparator it will be there. So out 1 will be, this is how it can be written. So if you will see now, temp is less than 6 less than 5 less than 3 plus temp, like that it will be written. So what it has done actually, see, these are the basically, see, multiplier optimization it is there, right? Temp star something 105 it is there, right? 105 it is there. So that one it has taken into a variable, then it has done that it is less than 6 for this one, less than for this one 5, for 3 and for 1. These are all logics, whatever the logics it will be present. Out 2 will be similar to that out 1. So out 1 means what, this temp star 105 this much that they have taken, then less than 9 for this 502, and then less than 2 for this one, right?
Right.
So these kind of, it's just the conversion. That's it. Why I'm showing you it to you guys also, that understand that these are the violation. Like these are the conversion. It is there. Someone is trying to come. These are the conversions. It is there, right?
Yes, sir.
Not getting bored with the digital logics. See, these. This is one that I will tell you. This is again I will tell you. This carry save addition, address subtractor multiplier. Why we are doing, just to make the circuit smaller and the faster. Smaller means area will be lesser, faster means area will be lesser and power will be lesser, faster means timing will be better, right? Second one, these are arithmetic operations, let's not spend much time there. You guys just note it down. You must have taken the screenshot, right? Sure. Load splitting and combo logic duplication. So here you understand, one AND gate is getting driven by 500 logics, right? Imagine how many logics are traveling from here. Like if it is coming right, so many switching activity will happen here, right? So either it can come forward also, backward also. So many capacitance will come. Whatever the this 500 logic it is driving, right? This can be divided into 250 and 250 logic. How it will divide? By cloning of this cell. What do you mean by cloning? Load splitting. What do we do?
Distributing the
Putting
load
the
same
same
load.
load, right? So that time that we can tell as it can be this and get might be here or might be here. Any situation can come. But why I have taken this one is like that we know that this is the fan out and from here it is. Hey, someone asked the fan out, right? I did not explain that. I forgot to explain that part. Hi, I will explain that now. So after this, we will go to the fan out only. So now understand. Now this is 250 logics, 250 logic, and this cell, extra cell has come into the picture. So this is combo logic duplication happens. This is also called as cloning. Note it down. Combo logic duplication or cloning. So whenever we have this kind of situations, that we do. Okay, this optimization we will do it from tomorrow. Today, let me tell you the fan out first. You guys want time to note it down? Because I'm assuming now you guys only said right. You guys are taking the screenshots. So now, see, one cell is there, one cell is here, one cell is here, another cell is here. Like it is having, imagine, it is having some this kind of 4, 5, and these are connected like this. With the same. This input is same. Okay, with the same. Okay, let me draw it in this way. Yes, this way you might be conclude. This is one resistor. Okay, take from here. Now this is the Q pin. Q. From here it is going to some logics like this is AND gate. This is some OR gate. This is some inverter. This is one more flop. These four logics. One more resistor is there. With this output, it goes to AND gate. This goes to like 3 input AND gate. Another 2 inputs are connected somewhere else. One OR gate, which is connected here, or like generally it will be connected like this, and then like this 50 flops are here. 1, 2, 3, 4, like this 50 flops are there. 50 flops are here. Now understand. This is one guy is able to drive. So from here signal will go. So one guy is able to drive these many people. These many people. And same guy is somewhere else in the design is driving 50 plus 3 logic, 53 logic. 4 logic or 53 logic. Understand. If you are going to lift some weight, if your capacity is to lift the weight is 20 kg or 25 kg or 30 kg, and that you can lift, that is your maximum limit. If I will ask you to lift the 50 kg, what will happen?
No, sir.
Injuries.
Yeah, injuries will happen. So that is what those injuries are happening to this pin. This pin. Understand why? How the capacitance is defined? If I will ask the equivalent capacitance, everyone see, look here. I have not told you this one. earlier. How capacitance will define? This capacitance will be there. This is grounded. This is one capacitance, right? This input capacitance will be there. This capacitance, this capacitance, this capacitance, right? These capacitance are in parallel or series. Tell me. One, two, three, four, five.
Parallel.
Parallel, sir.
Who are in favor of parallel? Who are in favor of series? Tell me, guys. I won't see. I don't have a stick that I will hit you. Don't worry. Tell me.
Silence.
Rise and
Parallel.
solve parallel.
Be confident. That's what the problem is.
Parallel.
If
Parallel.
you are going to interviewer, there also they will try to confuse you. But it depends on you, right? I have seen so many interviewers trying to confuse me. I will be like, you talk whatever you want to talk. Whatever I know, I will tell you. And believe me, they have given me much more like good ratings. So interviewer will try to confuse you, but you have to be very careful. What you are talking, you should understand. You have to be confident. Parallel. So what will be the equivalent resistance?
C1
This
plus
level I
C2.
am going. So you guys understand this level I am going. So take this. Don't like let it go. Take this. Tell me, Tejaswini.
C1 plus C2 plus C3. Like whatever.
One, two, three, four, five. Like five resistance capacitance are
Mm-hmm.
there, right? It is
Yeah.
C1 plus for this circuit C equivalent equals to C1 plus C2 plus C3 plus C4 plus C5, right? Now this circuit for this one it is capacitance is C50. This is much more bigger number than any of these number. This is C4. 4. This is 3. This is 2. This is 1. Clear this? This is clear?
Yes, sir.
Yes, sir.
What will be the capacitance here? For this one equivalent capacitance in scenario 2. C equivalent equals to
C1, C2, C3 until
C1 plus
C50.
C2 plus C3 plus C4 plus C50. Anyone is having any doubt in this one? Aditya, any doubt? Anyone is having any doubt?
No, sir.
What is name one?
Vaishnavi.
Vaishnavi. Any doubt?
No, sir.
Pakka.
हाँ sir.
Acha. See, now you have this. Now tell me which is higher, one C equivalent to 1 or C equivalent to? Which one will be higher?
2.
2. Now tell me if capacitance is high, what all happen here at this pin?
Delay, sir.
Delay is
Need to
more, right?
drive is delay.
Next, what else? Power will be more,
Charge.
right?
Charging or
Power dissipation.
discharging is more.
More power.
But power will be more consumption will happen. Now tell me whether this circuit is better for us or this circuit is better for us.
First one.
First one.
First one, right? So our aim to convert this logic to as much minimum as like this. Okay, that is where this is called fan out. Like fan out means how much fan fan out. How much is there? Fan out. One more term is there, fan in. Yeah, these are the digital electronics words. I remember slew, fan out, transition, fan in, all are digital third semester thing. Okay. Still, I'm telling you, but understand. Like maybe I don't know why you have forgot. At that time, you have not studied well. So fan in means what? Fan in means how much This is coming. How much logics are there for this one? This is fan in for this point pin, right? Similarly, for fan out, how many out are there for this pin? Fan out, note this point. Fan out will always happen from the output of any pin. Fan in will always happen to the input of the pin. Note it down these two lines. Fan out, fan in, or propagation delay. You guys remember?
Yeah.
Yes. How many of you don't know? Tell me. I will not tell you anything. I just want to know how many of you don't know propagation delay. Slew. Skew was also there, and that is there in all engineering colleges. This what is this RC network theory? We have studied so much, right? This equivalent capacitance, this finding out parallel. This we have studied, right?
Yes.
This is where I will tell you. This is where we people miss it, right? We people miss it, and then you know whatever the basics are there, right? Fundamental we forget, and then we actually jump on the higher things. We jump on what? We jump on interviews. What? We jump on what? Tools. We jump on designs. But understand, if you will get that, whether you will be able to literally you will be able to understand with that if what you will do with that. So first understand, right? This is called fan out. So that is where this scenario we have to avoid. We have to split this fan out in terms of like if this is 50, I will convert this to like 25 and 25. Then for this cell I will have to clone it. Clone it means duplicate this cell. For this input and this input will be same. I can duplicate it. Clear?
Yes, sir.
Any doubt anybody is having?
So one small doubt, sir. How can we know that this cell can drive many number of fan out?
That tool will tell you. This is very good question. Rakesh, right?
No, sir, Sujay.
Sujay, right? See, this tool will tell you that this much of this fan out is there, and based on that, they will tell you that this is R and this is C. Hence, that max fan out of this cell, whatever the cell it is there, right? If it is one drive strength cell, it will not be able to drive. If it will be four drive strength cell, 4x cell, it will be able to drive. Hey, I have to take that as well. Cell point of view also, I will tell you. I think I have taken in the PPT. DAV from it is somewhere VT percentage I have not taken. Okay, so good that you told the percentage. Fine. So this is what it is there. Any doubt anybody is having? From tomorrow
Sir, I have
we'll
a question.
continue to. Go
Sir,
ahead.
I have a question.
Go
Sir,
ahead.
as we are doing optimization to decrease the area, while cloning, won't we be increasing the area by?
What is your priority?
Sir, in the example you gave, you told him one of the points that we need to cover is area. So,
Area,
on the
correct,
basis
correct.
of that, I'm asking.
But you are forgetting these bases.
Yes, sir, correct.
So that is what my answer is. That what is our priority? We
Yes,
can
sir, I got it.
compromise with area. See, that's what I was telling you, right? If today in the evening, if I'm not going with my friend, I can compromise that part. But I cannot compromise coming here and losing the session. What we losing the momentum, what we are having right now, right?
Yes, sir.
If we will
Yeah.
lose this momentum, then again, if I will not come, I will prioritize the area. Like I will going out with my friend. What will happen? this will go collapsed, right? This training will collapse.
Yes, sir.
So what is my for this one? For this one, I can compromise with this one. So first thing is here, if you will see, power has also increased. Correct?
Yes, sir.
Extra cell will come. That will also consume. But timing we have to fix first, right?
Yeah.
Yeah, good, very good question. This is very good question. You have used your mind very nicely. This is this type of questions actually I'm expecting whenever I'm teaching. Very good.
Sir,
Hmm. Tell me.
you have one doubt, like you telling right, adders, subtractors, multipliers, all are having more delay, and so we are preferring half adder. So
Hmm.
will it not make a design bit complicated? We are clamped with more of half adder only.
Correct. See what will happen. I will tell you. If at multiplier is there, cell is big, area will be big. So there are so many complications inside that multiplier only. That multiplication takes longer time than half adder addition. So that is where we need to make it faster.
Okay.
So the only to make this faster and the circuit also, if you will see, if you will, that is where I have taken that. Next time I will just take few circuits, conversion circuits, like convert this to half adder, like that. Where is that? Some I will take it. So it actually makes your circuit smaller and faster. Actually makes your. So that is where we are trying to use the. See, if you remember the universal gates, what are universal gates?
And
NAND
and
and NOR, right?
norms.
So that we are using is, if you will use that, right, you will be able to have number of designs that you can convert it. You can convert it, but there are few things that more number of cells will come into the picture if
Yes,
you
sir.
are doing this arithmetic operations, right? Arithmetic circuits are there. So this, for this only we are to converting that. Good question. This is also very nice. Clear?
Yes, sir. Got it. Thank you.
Any other doubt? Tomorrow I will start with where is it? This one, synthesis optimization. So this I will tell you what boundary optimization is, what, how it happens. Then this is scan register. This is a very good topic, adaptive retiming. If you will ask your senior persons also, they will not be able to tell you, most of them. This is actually very good path group. This we need to understand because Qualcomm, I will tell you, if you are targeting Qualcomm or you are targeting Qualcomm in future also, they will ask you couple of questions from this slide. This slide. So how they will ask you, like what are you doing, how you are doing. Everything is not there in this slide, but I have taken my base thing just to explain you guys what else can be. Okay.
Okay, sir.
Okay, sir.
So one by one, let's understand this. Okay. Today I think we have, like, I wanted to complete so many things in optimization, but since we did that revision, that took us so much of time. It's okay. Okay, guys. So tomorrow, let's come back, and I see, like, so many, like, I have not seen the answers from every one of you for the, like, clock period and all. So if you are happy with this, enjoy your happiness. If you want to do that, or if you have any doubt in that, do ask me. I will explain you. I will tell you what to do, what not to do, like the how it will come, the circuit, how it will come. But if you will do that, remember that these two, never forget this. You will be asked. I know that many of you have done the this frequency divider. Frequency divider. This circuit you will get on Google, but this you will not get.
Yes, sir.
You search it out. I know that you will not get. So only thing is like try to make any combo logic. Think of it, revise your digital logic, think of it, try to make it. Come up with any circuit that will multiply your digital frequency. I will help you with that. But first, I want you to spend time here. If you will look for multiplier, right, you will have so many other circuits you will see. Okay? This clock pulse and all. Use your mind. It will boost your mind and confidence both if you are doing that. I will not point it out who has sent, who has not sent. I know who has sent, I know who has not sent, but I don't want to point it out. Okay, guys. Anything else? How many of you are going to office?
Kavya.
Come on, sir.
Rakesh, Kavya,
Yes, sir.
David.
David goes.
David, I know. Kavya, where are you working?
I'm working Excel VLSI technology, sir.
Acha, acha. So what you are doing there?
There they just giving us training, but still not got any clients.
So you should ask your trainer, right? I mean, every one of you, like most of you, I have interacted. I told you guys, right? You should ask your trainer that why not? I mean, why this is there, why that is not there. Who all are them? Like, it's a industry, like they are doing some designs, or who? It is like just a training thing, training program thing.
They are doing designs.
So, after doing designs, also they are not able to explain.
When we use people, they're asking more for 3 plus 5 plus year experience people.
I did not get. What is that?
They're all asking for like 3 plus 5 plus year experience people, so we have to wait.
Good one. One more thing also is there, like people. Whenever you go to people, right, and uh, if they don't know the answer, they will say that they are busy. That also happens many times. I have seen. So, but ask them like as much you can, and through the mail or through the communication or anything, right? Ask them. But good one, Kavya. Like carry on
Okay,
with it.
sir.
Yeah. Or you can ask here also if PD doubts are also there. If you want to ask anytime, like after 10, I can explain. Or like
Yes.
sometimes I will just ping in the chat box in the WhatsApp group that in 7:15 only sometimes I joined, right? So I will tell you that I have joined. If anybody want to connect or talk on anything, just come there and like we can talk.
Okay, sir.
That is also fine.
Thank
Yes.
you.
Thank you,
Yeah.
sir.
Yeah. Okay, guys. Thank you so much. Tomorrow we will again resume from here, and yeah, let's start from their optimization. Okay.
Thank
Okay.
you.
Okay.
Well, good
Thank you,
night. Take
sir.
care,
Thanks,
guys.
sir.
Thank you, sir.
Bye
Thank you.
bye.
Thank you, sir.